Doing the elevator problems now is like doing half of an Atwood machine problem. So let's take a look at the first one where we have the mass of the elevator is 450 kilograms. The mass of the person that's inside the elevator is 50. The acceleration is 1.2 meters per second going upward. And I want to know the tension in the cable and the scale reading of the person inside the elevator. So we have drawn these in class, so let's just go ahead and write down what's happening, right? I've got a person on a scale. I've got a cable up here. And so I have the mg of the elevator and the person, and then I have the tension that's on the rope. Okay, so all of our movement is happening in the x direction, or in the y direction, excuse me, and my acceleration is going upward. So the sum of my forces in the y direction is equal to mass times acceleration. The sum of those forces is going to be my tension minus mg. So I could say, this is a fancy therefore, T minus mg is equal to ma, and I can add mg to both sides, so my tension is equal to mg plus ma. Or I could write it as mg plus a. The only reason I would write it that way is so that I have less keystrokes on my calculator. So my mass is going to be 500 kilograms. That's my mass of the elevator plus the mass of the person. And then I'm going to multiply that by 10 meters per second squared plus 1.2 meters per second squared. So that tension, 500 times 11.2 gives me 5,600 newtons. So that's my tension. And then finding the scale reading, that's really finding the normal force, right? So I'm looking for the normal force of the person. So if I write that person down, right, that person is also accelerating at 1.2 meters per second squared going upward. And there is an mg going downward. And then the scale has a reading going upward that we're going to call the normal force. And it's really your effective weight or apparent weight. So this is the same situation, but instead of t, we're just going to put normal. So normal minus mg is equal to the sum of my forces in the y. Ma is equal to the sum of my forces in the y. So my normal minus mg is equal to ma. Add mg to both sides, and I end up with my normal force is equal to, and I'm just going to kind of go straight to this one, my mass of the person times g plus a. Right, so that's going to be 50 kilograms times 10 meters per second squared plus 1.2 meters per second squared. And the good news is that this particular thing is actually 1/10 of the other. So if I do 50 times 11.2, I'm going to get 560. It just happened to work out that way. So don't automatically think that it is going to be that way, 560 on all of these. All right, it's just the ratio that I gave you of the elevator when you take both of them together versus just the person. They're just, person is 10% of the overall total mass. Okay, so there's your first elevator.